Hey everyone, Mr. Creed here. I was aware that my last video for volume did not upload to either YouTube or Canvas, so we're going to redo this together. So we'll go over three examples. We'll go rectangular prism, triangular prism, and pyramids. Okay, in this case, we're going to talk about a square-based pyramid. All right, so we got a rectangular prism. Now, rectangular prism is like a box. Could be a shoebox, could be um, a box to hold toilet paper, a box to hold paper towels, whatever you can think of, maybe a cereal box too. So to find the volume of a rectangular prism, okay, think of like area. Area of like a two-dimensional shape, like a square, we gotta find this amount of space inside that square, okay, in just the face here. Volume, we are pretty much stretching this square along a third dimension. Okay, so to make this a three-dimensional object, we got to add one more section. We got to add one more dimension in there, which is called, I guess, the width of the box. We have the length and we have the height. That would be like in the original square, two-dimensional square. And if you were to stretch this thing out, we add an additional width in here. So we got the length, width, and the height. Okay, so to figure out what the volume is going to be, we do like we do with area. We just multiply all of those together to find the amount of space inside that box, or in this case, this rectangular prism. So we're going to multiply the length, the width, and the height together. So I've written down the formula for you. Volume equals length times width times height. In this case, the volume is we're going to replace these letters with the numbers. 3 centimeters times 5 centimeters times 4 centimeters. Okay, so we got volume equals. I'm gonna go ahead and combine these two. So these two become 15 centimeters multiplied by 4 centimeters, and then 15 times 4 is going to become 60 centimeters. Now, when we talk about area, we usually square our units. In this case, for volume, we're going to cube our units. So we're going to have 60 cubic centimeters. So the reason why for area we only do squares because we're only multiplying two dimensions, length and height, or width and height. In this case, we have for volume we're multiplying three dimensions, okay, that's why we're going to cube our answer. All right, so let's go on down. So that's pretty much basic, straightforward for a rectangular prism. You just multiply all these dimensions together, okay? All right, let's talk about triangular prism. Triangular prism has a very similar formula, with the exception that we're dividing that by 2. Okay, the reason why is that a triangle is essentially half of a square. Okay, if I were to cut that square diagonally in half, I will now be separated. I'll now have 2 triangles. So the area has been split in half, okay, of the original square. The same thing with triangular prism. The volume is going to be half of the rectangular prism. So we're going to take length times width times height and divide it by 2. All right, so let's go ahead and identify which dimensions are which. Okay, 4 is our height, 3 is our length, and 5 is our width. Okay, a little different order, but that's okay. All right, so we're going to replace these letters with the numbers. So we got the length, which is 3 feet, multiplied by the width, which is 5 feet, multiplied by the height, which is 4 feet. We're going to take all of that and we're going to divide it by 2. Now, if you remember, just above here, we've done pretty much the same dimensions. We've got 60 cubic centimeters. So 3 times 5 times 4 should give us 60. So I'm going to go ahead and use my prior knowledge there. And we're going to use 60 cubic feet. Okay, remember multiplying by 3 dimensions. So got to cube it. And we're going to divide that by 2. So the volume of this triangular prism is going to be 60 cubic feet divided by 2, which is going to be 30 cubic feet. Circle our answers, that way we are not confused of which is which. Okay? All right. Now, pyramid. Very similar again. Okay? Pyramids are a third of the size of a rectangular prism in volume. Okay? The amount of space inside that pyramid is 1/3 the size of a rectangular prism. So we're going to talk about a square-based pyramid. Okay, square base means that it has a square base, and all sides of the base are the same, 5 meters by 5 meters. Okay, the height of this pyramid is 4 meters. So again, we're going to identify which is which. So this could be length, this could be width, and this is height. Okay, so again, we're going to take these numbers and replace them in the letters in the formula. So we're going to take volume. Our length is 5. Our width is 5. So 5 meters times 5 meters times our height, which is 4 meters. And we're going to divide that by 3. Okay, so let's figure out what 5 times 5 is, or 5 times 5 times 4. So I'm going to go ahead and figure out what 5 times 5 is, so 5 times 5 is going to be 25 meters times 4 meters. Now, since I am multiplying, yes, that's fine. So all divided by 3. So we got 25 times 4. 25, I'm going to move up here. 25 times 4 is going to give us 100 cubic meters, all divided by 3. Now, 3 is a prime number, and it's only divisible by itself. 100 is not a prime number, so we're going to have a interesting answer here. We're going to have a repeating decimal. So we're going to give an approximate. So 100 divided by 3 is going to give us approximately 33.33 repeating cubic meters. Now, you can round this if you'd like. You can, in this case, we'd have to run it down to 33 cubic meters. In some cases, you'll just get this right here. If you want to do 33.33, or no, if you get a repeating decimal, that's okay. All right, as long as your math is correct. Okay, guys. I hope this has been helpful. I'll go ahead and post this on YouTube. And I'll go ahead and put it on Canvas as well, so you can watch to finish up your work for this week. Okay, stay safe out there. I'll talk to you guys soon.